Hey everyone, and welcome back for another deep dive. Remember back in the day waiting like forever for those web pages to load?
Oh yeah, the dial-up days. Screeching modem.
Exactly.
Yeah.
Felt like an eternity. It's crazy to think even our super fast computers today, they still hit those walls. They struggle when things get really complicated.
Yeah, some problems are just too massive for even the most powerful computers we have right now.
And that's where quantum computing comes in, right? So today, we're going deep into Google's latest and greatest, the Willow chip.
Some are saying this is a total game changer, like revolutionary.
Exactly. We've got a summary document here. It's based on Google's own video about Willow. And let me tell you, after going through this, I was blown away.
Yeah.
We're going to break down exactly what makes this chip so special, and by the end, you'll be able to decide for yourself. Is it all hype?
Or is it truly the future of computing?
Let's get into it. So first things first, for those who might not be familiar, what exactly is quantum computing? And more importantly, why should we even care?
It's not just like a regular computer getting a speed boost.
Right.
It's a whole different way of thinking about how we process information. Like it's a complete paradigm shift.
Okay. So how is it different?
Well, think about it this way. Typical computers, they use bits, right?
Right. Zeros and ones.
Exactly. Zeros and ones, on or off. But quantum computers, they use these things called qubits.
Qubits.
And a qubit can be 0, 1, or R, both at the same time.
Whoa. Okay, wait.
What?
Both at the same time? It's kind of hard to wrap my head around.
I know, right? It's mind-blowing. It all comes down to this concept in quantum mechanics called superposition. But to put it simply, imagine a regular computer is like a light switch. It's either on or off.
Okay, makes sense.
But a qubit, it's like a dimmer switch.
Okay.
It can be anywhere in between. It has a way bigger range of possibilities.
I see. So more possibilities means it can do more things.
Exactly. It can do calculations in ways that regular computers just can't, unlocking the potential to solve those massive problems we were talking about.
Got it. So that's like drug discovery, materials science, the stuff that takes forever, even with supercomputers.
Yep. Things that would take classical computers centuries, maybe even millennia, a quantum computer could potentially do in minutes.
Okay, now I'm really starting to see the potential here.
Yeah.
So where does this Willow chip fit into all of this?
So Willow, it's the newest kid on the block in Google's line of quantum chips.
Well, they've been working on this for a while, right?
Oh yeah, they've come a long way. They had foxtail, bristlecone.
And then the Sycamore, right? The one that made a big splash a few years ago.
Exactly. Sycamore was a huge milestone. Back in 2019, it actually achieved what we call quantum supremacy.
Quantum supremacy, it sounds intense.
It basically means it outperformed a classical supercomputer on a very specific task. It proved that quantum computers can actually do things that classical computers just can't handle.
So Willow's building on all that previous work then?
Exactly. It's an evolution, not a revolution. Each chip is built on the lessons learned from the one before it.
Okay, so it's not just some random breakthrough that came out of nowhere.
Nope. Google's been steadily pushing the boundaries of quantum computing step by step.
Got it. So this summary we have, it lays out some pretty impressive features for Willow. They're talking about a 5-fold increase in quantum coherence. What exactly does that mean? That word always trips me up.
I know, right? It sounds super technical, but it's actually a pretty simple concept. Imagine you're juggling, right? The longer you can keep those balls in the air, the more complex tricks you can pull off.
Okay, I like that analogy.
Quantum coherence is kind of like that. It's how long those qubits can stay in their super-powered quantum state, the state where they can be both 0 and 1 at the same time before they fall down and become regular old bits.
So the longer they stay up, the more powerful they are.
Exactly. And Willow can keep them up for 100 microseconds.
100 microseconds. And how does that compare to, like, Sycamore?
Well, Sycamore was only able to manage about 20 microseconds.
Wow, so that's like a 5 times improvement.
5 times longer coherence time? Yeah, that's huge.
Right.
It means Willow can do much more complex calculations before those qubits lose their quantumness.
So that's a big win for Willow, right? Longer coherence, more computing power. Okay,
Yeah.
I'm following. But what really caught my eye was this quantum error correction threshold. They say Willow's the first to operate below it. Now, I know errors are bad in any computer, but why is this such a big deal in the quantum world?
Okay, so this is one of the biggest challenges in quantum computing. Qubits, they're super sensitive, any tiny disturbance can knock them out of their quantum state and introduce errors into your calculations.
Right, and those errors can just snowball.
Yeah.
Right, making the whole thing useless.
Exactly. It's like building a house of cards. The bigger you make it, the more unstable it becomes and the more likely it is to collapse. Same with quantum computers. As you add more qubits to increase the computing power, the errors tend to multiply and it can crash the whole system.
Okay, so I can see how that would be a major roadblock.
But now, for the first time, Willow is operating below this quantum error correction threshold. What this means is that as the chip gets bigger and more complex, the errors actually decrease instead of increasing.
Wait, so it's like the more qubits you add, the more stable it gets? That sounds almost counterintuitive.
I know, right? It's kind of mind-blowing. But that's the beauty of quantum mechanics. It doesn't always follow the rules of the classical world.
So we can finally build large-scale quantum computers without them crashing every few seconds.
That's the hope. This is what scientists have been working towards for decades, and Willow's achievement opens up a whole new world of possibilities.
Possibilities like what kinds of things could we actually do with a large-scale, stable quantum computer?
The sky's the limit, really. Imagine being able to simulate complex molecules at an atomic level.
Okay, and why would we want to do that?
Think drug discovery. We could design life-saving drugs with incredible precision. Or we could create entirely new materials with unheard-of properties.
Okay, like super strong with super lightweight materials.
Exactly. Or materials that conduct electricity with zero resistance, leading to super efficient energy grids. The applications are endless.
Okay, I'm getting it. So it's not just about faster computers, it's about doing things that were impossible before. And Google's summary also mentions that Willow is insanely fast. They claim it can do a calculation in 5 minutes that would take a supercomputer 10 to the power of 25 years. That's a lot of years.
It's literally more years than the universe has existed.
That's just mind-boggling.
I know, right? It's hard to even comprehend the difference in scale. This isn't just about speed, it's about solving problems that were literally considered unsolvable.
Wow. Okay, so Willow is more coherent, it can scale up without being crippled by errors, and D, it's unbelievably fast. What else is there?
Oh, there's more. There's this thing called tunable qubits and couplers.
Okay, tunable. What now?
So imagine a computer that can change its hardware on the fly, like reconfigure itself to perfectly run any program.
Okay, that sounds pretty futuristic.
That's essentially what Willow can do with its tunable qubits and couplers.
So they're not fixed in place.
Nope. They can be adjusted and fine-tuned for each specific calculation, making the whole system incredibly versatile and efficient.
And I'm guessing that also helps with the whole error correction thing, right?
You got it. By being able to fine-tune the interactions between qubits, it's much easier to identify and correct those pesky errors. It's like having a built-in debugger that's constantly optimizing the system.
Wow. Okay, so it's fast, it's accurate, it's adaptable. It sounds like the ultimate computer. And Google's video, it hints at some pretty wild applications for this tech. Pharmaceuticals, better batteries, even fusion power.
Yeah, those are just a few examples. But think about the potential impact on, well, pretty much every aspect of our lives. Imagine personalized medicine tailored to your exact DNA, batteries that charge in minutes and last for weeks, clean and practically limitless energy from fusion power.
Okay, yeah, fusion power. That's like the holy grail of clean energy.
Right, exactly. And for a long time, it felt like it was always decades away. But with quantum computing, we might be able to crack the code much sooner than we thought.
Man, this all sounds incredible. But let's be real here for a sec. Isn't quantum computing still years, maybe even decades away from having any real-world impact? How confident are we that Willow can actually deliver on all these promises?
It's true that we're still in the early stages of quantum computing, but Willow represents a major step forward.
But a step forward doesn't mean we're there yet.
No, but it's pushing the boundaries of what we thought possible. If we can achieve this much already, just imagine what future quantum computers will be capable of.
That's a good point. The progress has been pretty rapid, even in just the last few years.
Yeah, it's accelerating exponentially. So even though we might not have all the answers right now, it's definitely something to keep an eye on.
Absolutely. So, to wrap things up, we've got this Willow chip from Google. It was building on years of research, and it's showcasing some truly groundbreaking capabilities. Longer coherence times, error correction that actually works, incredible speed. It's all pointing towards a future where quantum computers could solve some of humanity's biggest challenges.
And maybe even create a few new ones along the way.
Huh. That's a good point. So for all of you listening out there, If Willow, with all its mind-blowing features, is just the beginning, what do you think the future of computing holds? It's definitely an exciting time to be following this field, that's for sure.
Absolutely. Buckle up because things are about to get very interesting.
Couldn't have said it better myself. Thanks for listening, everyone.